Welcome back to session 21 of GED Science Mastery. Today we begin Earth and Space Science with the ground under your feet. Earth has layers. The crust is broken into moving plates, and plate boundaries explain many earthquakes, volcanoes, and mountains. We will also connect that to the rock cycle, how rocks form, break down, and change over time. These are very testable GED patterns, and they are easier than they first look. Start with the layers. From the outside inward, Earth has the crust, the mantle, the outer core, and the inner core. The crust is thin, solid rock. The mantle is thick and hot, and it flows very slowly over long time periods. The outer core is liquid metal. The inner core is solid metal, even though it is extremely hot because pressure at the center is enormous. GED questions often ask for the order or for which core layer is liquid. Earth's crust is not one unbroken shell. It is broken into huge slabs called tectonic plates. These plates move only a few centimeters per year, which is about the speed your fingernails grow. They move because heat inside Earth creates slow currents in the mantle. That slow movement is powerful enough to build mountains, open oceans, and trigger earthquakes. The movement is slow, but over millions of years, slow becomes enormous. Most geologic action happens at plate boundaries, where plates meet. If plates collide, crust can fold upward into mountains, or one plate can sink below another and feed volcanoes. If plates move apart, new crust can form. If plates slide past each other, stress builds and releases as earthquakes. So when a GED question shows a map of earthquakes or volcanoes, look for the plate boundaries first. That pattern is the evidence. The rock cycle is the slow recycling system for rocks. Igneous rock forms when magma or lava cools and hardens. Sedimentary rock forms when sediments are pressed and cemented together. Fossils are most often found there because layers can bury remains. Metamorphic rock forms when existing rock is changed by heat and pressure without fully melting. Any rock type can change into another over long periods of time. Now read the data. A geologist counted earthquakes by distance from the nearest plate boundary. Within 0 to 50 kilometers, there were 120 earthquakes. From 50 to 150 kilometers, there were 40. From 150 to 300 kilometers, there were 8. Farther than 300 kilometers, there were only 2. The pattern is clear. Earthquakes become much less common as you move away from plate boundaries. What pattern did the data show, and what does that suggest? Read. Earthquake counts drop from 120 to 40, then 8, then 2 as distance increases. Choose. Earthquakes are concentrated near plate boundaries. The closer you are to a boundary, the more earthquakes the data show. Check. Do not overstate it. Earthquakes are far more common near boundaries, but the table still shows 2 far away, so do not say they are impossible elsewhere. 3 quick links help with many questions. A fault is a crack where rock slips, often causing an earthquake. Volcanoes often form where one plate sinks beneath another, melts, and feeds magma upward. Fossils are most often found in sedimentary rock because sediment can bury remains before they decay or wash away. When the GED gives you a location, a rock type, or a feature, ask what process made it. Let's lock in the traps. 1. Thinking the inner core is liquid. No, the outer core is liquid and the inner core is solid. 2. Thinking plates move fast. No, they move only centimeters per year. 3. Thinking earthquakes are random everywhere. No, they cluster near plate boundaries. 4. Mixing up rock types. Igneous comes from cooled magma, sedimentary comes from sediments, and metamorphic comes from heat and pressure. The recap: layers, plates, boundaries, and rock cycle. Excellent work today. You can now name Earth's layers, explain why earthquakes cluster near plate boundaries, and identify the three main rock types. Your practice for this session is the 10 questions attached to this lesson. Before you answer, look for the pattern: location near a boundary, the direction plates move, or the process that forms the rock. To read the full lesson notes and practice more GED science questions, visit the course page at www.bridgetoexam.com. I will see you in session 22, where we study water, weather, atmosphere, and climate.